This video aims to give you an overview of a set of civil engineering drawings. You will be able to navigate a set of plans quickly and be able to recognize applicable information for the task you are doing. The title page will tell you the project name and revision the set of plans apply to. A set of plans for any project goes through many revisions over many months or years. Check with your supervisor or coordinator to ensure you are using the most recent revision. The IFC, or Issued for Construction label, states that the plans have been approved for construction to begin. Before the approval is given, plans are labeled as NFC, or not for construction. NFC plans are for reference only and cannot be used during construction. This set is revised for final submission, which would mean we should not be using them for construction. But there is a signed stamp in the bottom corner stating they are approved for underground and surface construction. The index serves as a table of contents. Each page in the set is listed in order. In a large set of plans, using the index can save a lot of time. Usually the next section will have the cover sheets. There are several cover sheets, each applying to different parts of construction. Typically you will find cover sheets for surface improvements, sanitary, storm, water, building grade plan, storm drainage calculations, erosion and sediment, and overland drainage. This video will examine the cover sheets which apply most directly to underground and road construction. The first cover sheet in this set is the Surface Improvements cover sheet. We'll take a look at the page as a whole, as all the cover sheets have a similar layout with common components. Starting on the right side, there is the information of the engineering firm that prepared the plans. You might also see information for other entities working on the project, such as consultants and owners. The Notes section lists the path this set of plans has taken to becoming issued for construction. Once a set of drawings has become IFC, changes still occur. Sometimes this information is useful for determining the revision date of the plans if you don't have the cover page. There is a space for the engineer's official seal or stamp. It is very common for the bottom right of the page to have the page title and page number. This makes it easier to locate a page when flipping through the pages of a large set. Finally, you see a scale. There is a ratio and a graphical representation of linear measurements. On a properly scaled printed set, you can use the ratio and a scaling ruler to measure distances. Alternatively, the graphic is helpful to get approximate measurements of feature on the plan. Some engineering firms place this info along the bottom of the page, but you will notice the information is very consistent from project to project. We'll avoid the actual drawing for the time being and examine more of the surrounding information. You'll find boxes with various notes in them regarding important aspects of construction. Depending on your role in construction, this information could be vital. A legend shows the standard lines and symbols you'll find on the plans along with a description of each. Be aware that plans are often created in color, but you may only have a black and white printed version. Two similar-looking lines on the drawing may represent two completely different structures. The pavement design chart can sometimes be found on plans, and they detail the structure of each road. This determines the total structures of gravel and asphalt for all areas on site. Before you start construction, it is still recommended to find and double-check these numbers with your supervisor, because the engineer may change them for a variety of reasons. On this page, there are small drawings called details. These give us a detailed look at the design and dimensions of a variety of things, including concrete structures, as shown here with concrete swales, manholes, valves, or anything else the engineer feels is necessary to help us build the road. Note that they are labeled as they are referenced in the main drawing. This note here for the T intersection of a deep swale says to refer to detail C. In this case, the detail is at the bottom of the page. Sometimes it's on another page. It depends on the set of plans you're using. Another type of note refers to specifications. Specifications are standardized drawings for common structures found on jobs. These include different types of curb, pipes, roads, lanes, walkways, etc. You can find specifications in the spec book for whatever municipality governs at the applicable job site. In our case, it is very often the city of Calgary. Finally, there are cross-sections. This is a good time to discuss the different ways a drawing can look at a job. There are three main ways to draw a portion of a road: plan, profile, and cross-section. Take for example a straight flat section of road. The plan view is looking down on it from above. Profile view is looking at it side-on, along the road's length, and cross-section is a front-on look, showing the road left to right. You will see all three views in nearly every set of plans. This concept is important. It might become clearer later on as we see the other views, but be sure you understand the different views before interpreting a set of plans in the field. On the next page we see a small section of road that didn't fit on the last page. Large sites can take 5, 10, or dozens of pages to show the full scope of the job site. We also see several cross-sections, but this time referring to the road. The cross-sections here give measurements of road width, concrete structures, road and shoulder slopes, as well as some underground information. Note how they are labeled and how they are represented on the drawing. The arrows show the orientation of the cross-section, which is helpful if the road isn't symmetrical. Now to the actual drawing. Going back to the previous page, we see a plan view of the surface improvements cover sheet. The basic shapes of the roads, sidewalks, pathways, and lanes are pretty easy to understand, as are the names of the roads. There is a bunch more information packed into the drawing, which might seem daunting at first. Let's start with the numbers we see on the drawing. Block numbers have no circle and give a name to areas surrounded by roads and/or parks. These are used by engineers to plan utility needs. These are helpful when you are referring to the location of a specific lane. Lanes do not have names like streets and roads do, and therefore it is helpful to say the lane in a particular block number. For example, this lane is in Block 2 of Livingston Phase 4. Lot numbers are written a little smaller and label each lot within a block. The lot number identifies individual properties. They do not represent the address number of the property. Profile numbers are one of the most important numbers here. Profile numbers are usually drawn with a circle around them. They are a reference to a profile drawing later in the plans. Profiles show in detail information along a section of road. Each section of road or lane will have a profile number and page. On this page, we can see several profile numbers, each referring to a specific section of road. If we check now, you can see the section of Livingston View between First Street and McAdams Rise is 232. A quick glance at page 232 in your set of plans shows us how Livingston View grades along its length, with a lot of other information. We'll explain profiles a little later. Before we move on, there is an important line to pay attention to. The limit of construction, or LOC, is usually a thick, dashed line showing exactly where the construction is to take place. Often the drawing will be larger than the actual work area, but the extra information is helpful for orientation or simply a wise use of space on the page. The job contract will only allow for construction within the boundaries of the LOC, and work outside the boundary might not get paid for without special permission from the consultant. The following pages in this set are the turning templates. Engineers use these to prove large vehicles, such as buses, sanitation trucks, and/or tractor trailers, can safely navigate the roads as designed. We often disregard these pages as they do not apply to the construction of the road. The sanitary cover sheet has information regarding the locations of sanitary manholes and pipes. The sanitary water system carries wastewater from homes and buildings to wastewater treatment facilities. Notice that the block, lot, and profile numbers are on this cover sheet, the same as they were on the surface improvements cover sheet. Each manhole is represented by a circle or square labeled with its name and elevations of the rim and inverts. The rim is the top of the manhole cover when it is installed to final grade. The final rim elevation might differ from the plans for a few different reasons, so don't take it for gospel. The invert is the bottom of a pipe entering or exiting the manhole. This is important to have proper drainage. Each pipe is labeled with its size, type, length, and slope. The example here shows the pipe is a 250 mm PVC sanitary pipe with a length of 181.69 meters and a slope of 1.4%. Finally, each pipe has an offset from property line or PL to show where it is to be installed. The storm cover sheet includes storm manholes, pipes, and catch basins. The storm water system carries water from rain and snow to existing bodies of water, such as streams, rivers, lakes, and reservoirs. Similar to the sanitary cover sheet, the manholes have a name, rim and invert elevations, and the pipes have information about their size, type, length, slope, and offset from property line. One other thing this page shows well is a match line. Often, a single job site cannot be shown on a single page at a certain scale. The solution is to show the job over 2 or more pages. The match line is where the 2 pages would meet if you cut them out and tape them together. The water cover sheet includes information about valves, fire hydrants, and water lines. Essentially, this system feeds water to the houses and buildings along the road. Valves are represented by an X, Hydrants are shown with their standard symbol, along with their location in reference to property. The pipe is labeled with its size, type, and offset to property line. Other features include pipe intersections, bends, reducers, insulation, and notes. Each set of plans differs, but you will often see a number of cover sheets which contain information not useful to you. For instance, this set contains several of these, including the building grade plan, which is used more to calculate drainage, as does the storm drainage calculations, storm drainage, erosion and sediment, and overland drainage cover sheets. They are worth taking a look at when you have time, but do not typically aid in the actual construction of the road. Profiles, however, contain critical information for us. If we take a look at the profile page, we see it's split into 3 separate sections. We'll deal with the top 2 for now. Essentially, the top section is a portion of the surface improvements cover sheet. The road will always be laid out left to right, regardless of its orientation on the plan. That said, pay attention to the compass rose, as it will tell you where north is. In the top section we see information for the road, concrete, paths and lanes. We'll take a look at what all this information means, but first we have to cover a few important terms and codes. The lip of gutter is the front edge of a curb. On plans it is labeled as LOG, or just LG. Back of walk is the edge of a concrete separate walk. On plans it is labeled BW. Property line is the legal boundary of a building lot. On plans it is labeled PL. Curb and gutter is the full curb structure from lip of gutter to back of curb. On plans it is labeled C and G. There are plenty of other codes and short forms in the plans, which are sometimes listed in a legend on the same page, or near the front of a set of plans. If you can't find an answer from the plans, ask your supervisor. On the north side of the road we see words and numbers along the lip of gutter. BW 0.30 means the back of walk is 0.3 meters from property line. LG 5.05 means the lip of gutter is 5.05 meters off the property line. 0.25 RC and G means the curb is 250 millimeters curb and gutter, with the R meaning the curb is rolled. Pay attention, as there are sometimes similar codes that mean completely different things. For example, we see another R elsewhere, but it refers to the radius of a curve. In this case, the curb has a 9-meter radius. 7.70 pavement means the road is 7.7 meters wide, lip of gutter to lip of gutter. Plans prepared in Calgary follow this standard, however some follow different standards. Be aware of the source of the plans you are looking at. In the median, 0.25 STD C&G Rev means there is a 250 millimeters reverse standard curb and gutter. 3.50 median means the median is 3.5 meters wide from lip of gutter to lip of gutter. R 1.75 means the radius of the curve is 1.75 meters. We can also clearly see where concrete structure changes occur. For example, at the bus pad labeled BP, we see STD, C and G. This means that for the 10-meter section in front of the bus pad, there is standard curb, not rolled. In sections where the lip of gutter and property line are not parallel, the plans will state LG varies along the lip of gutter. Like we said earlier, the goal of being able to read a plan isn't just to read for pleasure. The plans are a tool to help you build the road. How do you actually use this information? Let's take an example where your crew has to start building the 2-meter separate walk, but there is no survey to tell you where the walk goes. All you have is the curb that is already installed. You know the cross-section will look something like this, but you don't know how far the front of walk is from the back of curb. It is helpful to start with a diagram like this and fill it in with the information from the plans. The plans say that the back of walk is 0.3 meters from the property line. The separate walk is 2 meters wide, and the lip of gutter is 5.05 meters from property line. When we place those numbers on the diagram, we are almost finished. Remember, our goal is to be able to pull a tape measure from the back of curb to find the front of walk. The only measurement left to find is the width of the 0.25 rolled curb. For that, we need to look up the city spec. We see that the spec shows 525 millimeters or 0.525 of a meter. Now we can figure out the distance from back of curb to face of walk by simple math. The total distance from property to lip of gutter is 5.05 meters, and by subtracting the known distances we are left with the measurement we're looking for. We pull a tape 2.225 meters from back of curb to find our front of walk, and subsequently 4.225 meters to find our back of walk. Now back to the profile page. Looking to the middle section is a combination of sanitary, storm, and water information. This section essentially shows all the information from the sanitary, storm, and water cover sheets for a specific section of road. You can see all the storm and sanitary manholes and pipes, as well as the water valves and hydrants. Notice how the top two sections line up with each other vertically. You can take a ruler and match up features from each section. This is important, as it also corresponds with the graph in the bottom section. The graph shows the profile view of the road, as if you sliced it along the length of the road. Let's first look at the scale. On the right side, we have the vertical scale, which states each horizontal line is equal to 0.2 meters. So 5 lines equals 1 meter. The horizontal scale is different. Each vertical line is equal to 10 meters. This exaggeration allows for all the info to be squeezed into the space available. Another key concept is stationing. Every road has an alignment, which is basically a centerline used for distance and location referencing. A station is simply a point along an alignment. For example, a 200-meter road could start at station 0 plus 000 and end at 0 plus 200. Note the format of the stationing. It usually has the plus. A station 1500 meters past station 0 plus 000 would be noted as 1 plus 500. Sometimes, alignments don't start at 0 plus 000, but use the first number as a way of labeling the alignment differently from other alignments. For example, there might be 3 alignments, but the first starts at 10 plus 000, the second starts at 20 plus 000, and the third at 30 plus 000. There is no set standard on naming alignments. The important thing to remember is that stationing refers to a distance along a line and can help you find a location along that line. As we mentioned before, profile refers to a side-on view along the road. Again, there is a bunch of lines and words which can look intimidating, but we'll break it down into individual components. The first line we'll look at is existing ground. This is where the ground was as the design process began. It helped the designers use the material on site most effectively. Next, the lip of gutter lines show the vertical path the lip of gutter will travel along the road. A quick glance at this, and we notice 2 lines for lip of gutter, LGM, and LGN and S. LGM means median lip of gutter. LGN and S means lip of gutter for both north and south edges of the road. This example tells us the median curbs are at a higher elevation than the outside curbs. You might see LGW or LGE, depending on the orientation of the road. Aside from the label, there is more information about the lip of gutter, such as the slope. On sections with constant slope, it's listed as a percentage. This is used to help determine the height of crown on crowned roads. Where the lip of gutter curves from one slope to another, it is called a vertical curve. Roads cannot simply go from one slope with a hard break into another slope. The vertical curve between the slopes make for a more comfortable ride for the drivers on the road. The curve is based on the angle in and the angle out. Where those meet is called the vertical point of incidence, or VPI. How this is drawn on the plan is as follows. This is where the info above the profile comes into play. The plan will state the station of the VPI as well as the elevation. Note, this is the elevation of the VPI, not the lip of gutter at the VPI. Some plans will show the lip of gutter elevation as well. The length of the vertical curve is also listed. This will show where the vertical curve starts and stops, and corresponds with the hash marks on the lip of gutter below. In this example, the VPI is at station 0 plus 361. The slope into the vertical curve is 2.099% and the slope out of the vertical curve is 3.55%. The VPI on the north and south lip of gutter is 1,123.774 and the median lip of gutter is 1,123.928. The length of the vertical curve is 40 meters. Below the lip of gutter lines, we see the lines for water, sanitary, and storm pipes. They are all labeled with their size and type like on the cover sheets we saw earlier. The lines for all pipes refer to the invert line unless otherwise noted. Again, the invert is the bottom of the pipe. At each manhole, you'll notice the name and rim elevation, as well as the type of manhole listed on the vertical line below. At the bottom, you see the invert elevations also. In this example, the manhole is labeled as STMH, or Storm Manhole 4-3. It is a Type IS. with dimensions of 1220 by 1220 millimeters. The rim elevation is 1123.35 and inverts at 1118.660 and 1117.760. From this information, you can assume if you look down the manhole, you would see two connecting pipes, one about 4.5 meters down from the rim, and another about 5.5 meters down. Overall, the profile pages are incredibly important tools to help you visualize the road before it's built. As you gain experience in the field and in reading plans, you can foresee and solve problems in the design before construction is finished. For example, we can see the lip of gutter creates a low spot here. Water will flow from the east and west and collect here. From our knowledge as road builders, we would expect to see a catch basin to collect and remove the water from the roadway. We can check the design by following vertically up to the middle section, and we find a catch basin is indeed designed in the proper place. Follow that line into the top section, and we see the catch basin is just west of a wheelchair ramp. If the catch basin were in front of the wheelchair ramp, the grate could trap the wheels of a crossing wheelchair, causing a safety issue. This example shows the interconnectivity of all parts of the design. The design process is complex, and mistakes happen. With the knowledge from this video and your experience in the field, you'll be able to do your job better with a greater understanding of how and why roads are designed and built the way they are. With time and practice, you will be able to read plans efficiently and potentially catch design issues before they become major problems. In this video, we've covered the basics of how to read a set of plans. Specifically, you can navigate the set of plans using the index, understand the information on important cover sheets, read and interpret information of profile pages to visualize the road before and as it's being built. This video is just an overview. There is more to learn in these pages. Practice and understand the concepts you've learned, but also challenge yourself to do and learn more. Ask questions of your supervisors and have discussions with your fellow crew members. The more we all know, the better work we can do together.